Hi, this is Mrs. Kidman, and in this video, I'm going to be reviewing how we graph using vertex form. Now, when we talk about graphing a quadratic in vertex form for a quadratic looks like this. F of x equals a times x minus h squared plus k. Now, you may be looking at this and being like, wow, that looks really familiar, and that's because it is. In chapter 1, we discussed the absolute value function, and when we looked at our absolute value function, we looked at it in vertex form. So this vertex form here gives us these clues as to what happens. Remember, our vertex, when we're in vertex form, is just going to be the point hk. So whatever our h value is here, whatever this number is, that's going to be our x value, and our k is going to be our y value. The reason why that's important is remember in our absolute value function how that k told us where it moved up and down, and that h told us how it moved left and right. The same thing happens here. So this a, h, and k tell us how our function shifts depending on what we're doing. And we can use that shift to figure out where it is. Now, if we didn't want to do it that way, we could also graph our vertex and then use our a value to determine what those other points are. It's kind of up to you. I love to just shift my graph. I think these transformations are super fun, and it makes it a lot faster than trying to plug in all these points and do all these calculations. So I'm going to review over how we can use a, h, and k to shift our function around. So we're basing it originally off of our f of x equals x squared and getting it to our new function here. So as a quick review, we're going to talk about what do each of these letters mean. So remember, our vertex, this is super important, is the point hk. So whenever we need it, that's our vertex. Now, to determine how this shifts, what we can do is we can look at these points. So this k, when k is positive, it's going to shift us up. When k is negative, it's going to shift us down. Okay, up and down. Our h value is very similar, but instead of having our vertical shifts, it has our horizontal ones. So when h is positive, it goes to the right, and when h is negative, it goes to the left. Now, I'm going to include an example of what this looks like and identify each of these parts because this h value is where a lot of people get mixed up. When we talk about h being positive, that means that the place where that letter h is a positive number. But notice how there's a subtraction sign before it. So a lot of people get mixed up because when h is positive, our formula actually says x minus whatever that number is. So it's going to be x minus 2. And if it says x minus 2, then h is positive, so we're going to the right. But it looks like h is negative because of that subtraction sign. So keep in mind that it's kind of going to be the opposite of whatever we see. If I see x minus h, then h is positive, and we go right. If I see x plus 3, then that h is a negative number. It's a negative 3, and we're moving to the left. Then finally, we have this a value, and this a value is what we were talking about before. This controls two things. It controls our vertical shrink and stretch and our direction of our opening. So if a is a positive number, then it's going to open up, and it's going to look like that smiley face that we've seen. If a is a negative number, then it's actually going to open down, and it's going to look like a frowny face. So that's that first element of it. Then we need to talk about the number a itself. So if a, I'm going to write it as the absolute value of a. So if our number there is greater than 1, so 2, 3, 4, 5, the absolute value of it would also be like -2, -10, things like that. Then we are going to have a vertical stretch. And that vertical stretch means that our function is going to get thinner. So if here's my original function, this is going to be my new function. It gets thinner. If our value for a is between 0 and 1, whether it's positive or negative, then we have what we call a vertical shrink. And we call it vertical shrink because the distance that it has to go reduces. So if that black one is our x squared function, a vertical shrink widens it out. Okay, so that's kind of how that looks. So as an example here, just for a reference point, when we're talking about this, if we have f of x equals -2x plus 3 plus 2, what these numbers mean is this plus 2 tells me it goes up 2. This plus 3 tells me it goes to the left 3, and this -2 tells me it's going to do two things. open down, and it's going to have a vertical stretch by 2. Okay, so that's what this function does. And so as we graph it, that gives us our directions. So say I'm starting here with my original function, bam. What these directions do is it tells me where my function is going to move here. So this +2 tells me I'm going up 2. This +3 tells me I'm going to the left 3. That -2 tells me I'm actually going to flip over completely, like this. Ooh, maybe. And we're gonna move ourselves down here. So remember, up 2, over 3, and then that -2, that 2 tells me that my function is actually going to get thinner here. Oh, not wider, it's gonna get thinner, just like this. So do you see how my function changed? Originally, we had our function right here is this green one, and now we have one that's thinner and in a different location. And our vertex has changed. Originally, our vertex was here at 0, 0. Our new vertex is over here at -3, 2. And that's how it's going to change. So using this vertex form, we are going to practice graphing. And we can do that just using these directions. So as we practice this graphing, let's take a look at this first example here. So I want to graph f of x equals x squared and g of x equals -2 x plus 2 squared plus 3. Whoa. So I'm going to start by just graphing my original function. Okay, here is that x squared. Now I want to start in the same place. So I'm going to take this green one and trace it. Now my green one is going to be my new one here. Okay, this one's going to be the green one. Now these parts each tell me different directions. So this -2 here, this tells me that it's going to open down and get a little thinner. So I'm going to do that in 2 separate parts. I'm going to start by having it open down. Okay, so we're going to start by taking our green function here. Oh, we don't need all of this. We're going to start by taking this green function here, and I'm going to turn it upside down. Okay, by turning it upside down, that takes care of that negative element that we had there. So here it is, moved upside down. Okay, so I moved it upside down. That's what the negative tells us. Now, what do my directions say? That +3 tells me it's going to move up 3. And that +2 tells me it's going to move to the left 2. And then this 2 tells me my function has to get thinner. So I'm going to make my function thinner. And it's still going to be at that +3 over 2. So here is that new function that we have here. After we've moved it all around, we are back. And this is what that function would look like. Now, the other way that we could graph this function, if we wanted to do it, would be to graph it. Here's our original function, and to just move our vertex. So remember, our vertex here is going to be at -2, 3. So I'm going to want to move to -2 up to 3. And here we are, right here, -2, 3, something like that. Okay, and now that we're at this -2, 3 here, right here, I've got my point. Now this -2 tells me what my function is going to look like. It's going to be open down, and it's going to be a little bit thinner than the original one. Okay, if I wanted to find those exact points, I could, but we don't have to. So it's going to get thinner there. And as we found those exact points, we would want to substitute numbers in. A lot of the time, we like to find our y-intercept, and that gives us a great reference point. But either way, you can either use the directions or use that vertex to move it, and it all works the same way. So I want you to try one of these all on your own. We're going to do this number 6. So take a moment, pause the video, graph this function either using your vertex and what that A tells us, or graph it using those 3 directional moments, and then unpause the video and check to see if your graph looks the same. Okay, hopefully you've had a chance to go over these. Now, as we compare these 2 graphs, we were comparing it again to that f of x equals x squared. So I have that one graphed in green. My other function, that g of x, I have graphed here in blue. Now, as I read this equation, what I saw is that I needed to go up 6 to the, not the left, but to the right one. Whoops, my bad. Up 6 to the right one, just like that. And then, I always make mistakes, to the right one, and then a vertical stretch of 3. So we want to move to the right one. So as we write down these directions, we can see what our function ends up doing. And you can see that our function moved up 6 to the right one and then got a whole lot thinner. And as we did that, that's what our graphs looked like. We could graph with our vertex. Now our vertex in this case is going to be 1, 6, and we can see that that's this point right here. And then we could say, oh, instead of going up 1 over 1, I'm going to go over 1, up 3, and graph it that same way. Either way works great, but that is how we would graph quadratics in vertex form. We want to use that vertex form to find our vertex and then use those use the numbers to describe the transformations or the movements of our graph.